Hello everyone, welcome. I'm Professor Diwa, and in this video I'll be going over absolute value inequalities. The objectives for this video are to solve absolute value inequalities of the form absolute value capital X less than A. Solve absolute value inequalities of the form absolute value capital X greater than A. Alright, so let's get started. First, we will go over several rules for solving equations and inequalities with a greater than 0. The first rule states, if a is a positive number, then the absolute value of capital X equals a is equivalent to capital X equals a or capital X equals negative a. Now this is actually the same rule that we saw in the previous section. For rule number 2, it states, if a is a positive number, then the absolute value of capital X less than a is equivalent to negative a less than x less than a. Note that this rule holds true if the symbol were less than or equal to. We would just need to change all of the less than symbols in this rule to less than or equal to. Moving on to rule number 3, if a is a positive number, then the absolute value of capital X greater than a is equivalent to x less than negative a, or x greater than a. Note that this rule would still hold true if the inequality symbol was greater than or equal to. We would just need to add an equal sign to all of the inequality signs in this rule. In the next set of examples, we'll go over how to apply these rules. In example number 1, part A, we need to solve the absolute value of negative 3x plus 2. Outside of the absolute value, we have plus 4 less than 14. The first thing we need to do before we apply an absolute value rule is isolate the absolute value on one side. First, I'm going to get rid of the positive 4 by subtracting 4 from both sides of the inequality. Simplifying the left-hand side, positive 4 and negative 4 cancels out, and then we bring down the absolute value of negative 3x plus 2. On the right-hand side, we have 14 minus 4 gives us 10. So the result is the absolute value of negative 3x plus 2 less than 10. Next, we could apply the second absolute value rule since we have that the absolute value is less than a positive number. Applying the second rule, we can rewrite our absolute value inequality as negative 10 less than minus 3x plus 2 less than 10. Solving this compound inequality for x, we first need to get rid of the plus 2 in the middle. So we subtract 2 from the left side, the right side, and from the middle. Simplifying the left-hand side first, negative 10 minus 2 is negative 12. In the middle, we have plus 2 minus 2 cancels out, and we bring down the negative 3x. On the right-hand side, we have 10 minus 2 is 8. The result is negative 12 less than negative 3x less than 8. The next step is to get rid of the negative 3 in front of the x. We do this by dividing the middle, the left, and the right-hand side by negative 3. So we get negative 12 divided by negative 3 less than negative 3x divided by negative 3 less than 8 divided by negative 3. Simplifying the left-hand side, negative 12 divided by negative 3 is 4. Simplifying the middle, we have negative 3x divided by negative 3 is x. Simplifying the right-hand side, 8 divided by negative 3 just stays the same. So the result here is 4 greater than x greater than negative 8/3. Notice here that I flipped the inequality signs in the opposite direction because in the previous step we divided by a negative number. Note that we could also read this inequality as negative 8/3 less than x less than 4. The reason why I'm reading our inequality this way is because for our final answer, we need to write it in interval notation. When we use interval notation, you always go from smallest number on the left to the larger number on the right. For our final answer, we write parentheses, negative 8/3, comma 4, close parentheses. Moving on to part B, we have the absolute value of 3x minus 5. Outside the absolute value, we have plus 2 greater than 5. To solve this absolute value inequality, we first get rid of the plus 2. To do this, we just subtract 2 from both sides of the inequality. Simplifying the left-hand side, we have plus 2 minus 2 cancels out, and we bring down the absolute value of 3x minus 5. On the right-hand side, we have 5 minus 2, which is 3. So the result is the absolute value of 3x minus 5 greater than 3. Now that our absolute value is isolated on one side, you can see that we have an absolute value greater than a positive number. This means that we can apply our third rule. So we could rewrite this absolute value inequality as 3x minus 5 less than negative 3, or 3x minus 5 greater than 3. Solving the first inequality, we get rid of the minus 5 by adding 5 to both sides of the inequality. Simplifying the left-hand side, the minus 5 and the plus 5 cancel out, and we bring down the 3x. On the right-hand side, the minus 3 and the plus 5 gives us 2, so we have 3x less than 2. From here, we get rid of the 3 in front of the x. We just divide both sides by 3. So we get 3x divided by 3 less than 2 over 3. Simplifying the left-hand side, 3x divided by 3 is x. On the right-hand side, 2/3 will stay as 2/3. So the result is x less than 2/3. Moving on to the second inequality, we get rid of the negative 5 by adding 5 to both sides of the inequality. Simplifying the left-hand side, the minus 5 and the plus 5 cancel out, and we bring down the 3x. On the right-hand side, we have 3 plus 5, which is 8. The result is 3x greater than 8. From here, we get rid of the 3 in front of the x. We just divide both sides by 3. We get 3x divided by 3 greater than 8/3. Simplifying the left-hand side, we have 3x divided by 3 is x, and on the right-hand side, 8 over 3 stays as 8 over 3. So the result is x greater than 8 over 3. Next, we write our final answer using interval notation. So we have parentheses, negative infinity, comma 2/3, close parentheses, the union sign, parentheses, 8/3, comma infinity, close parentheses. Next, we have a practice problem for you to solve. For part A, we have 5 plus the absolute value of 3x minus 4 greater than or equal to 16. For part B, we have 3 times the absolute value of 2x plus 1 less than 9. Okay, so pause the video, work out these problems, and then check back with the video to see the solutions. Alright, so let's get started with part A. For part A, the first thing we need to do is isolate the absolute value on one side. So first, I'll get rid of the plus 5 by subtracting 5 from both sides of the inequality. So on the left-hand side, the 5 and the minus 5 will cancel out, and we bring down the absolute value of 3x minus 4. On the right-hand side, 16 minus 5 is 11. The result is the absolute value of 3x minus 4 greater than or equal to 11. Applying the third rule, we could rewrite our absolute value inequality as 3x minus 4 less than or equal to negative 11, or 3x minus 4 greater than or equal to 11. Starting with the first inequality, we get rid of the minus 4 by adding 4 to both sides of the equation. Simplifying the left-hand side, the minus 4 and the plus 4 cancel out. We bring down the 3x. On the right-hand side, minus 11 plus 4 is negative 7. The result is 3x less than or equal to negative 7. From here, we get rid of the 3 in front of the x. We just divide both sides by 3. We get 3x divided by 3 less than or equal to negative 7 over 3. Simplifying the left-hand side, 3x divided by 3 cancels out and leaves us with an x. On the right-hand side, negative 7 over 3 stays as negative 7 over 3. The result is x less than or equal to negative 7 over 3. Moving on to our second inequality, we get rid of the minus 4 by adding 4 to both sides. Simplifying the left-hand side, minus 4 and plus 4 cancels out, and then we bring down the 3x. On the right-hand side, 11 plus 4 is 15. We get 3x greater than or equal to 15. Next, we get rid of the 3 in front of the x by dividing both sides by 3. We get 3x divided by 3 greater than or equal to 15 over 3. Simplifying the left-hand side, the 3's will cancel out and give us an x. On the right-hand side, 15 divided by 3 is 5. The result is x greater than or equal to 5. Our final answer, we write it in interval notation. I have parentheses, negative infinity, comma negative 7/3, close bracket, union, bracket 5 comma infinity, close parentheses. Moving on to part B, the first thing we need to do is isolate the absolute value on one side. So we need to get rid of the 3 by dividing both sides of the inequality by 3. So we get 3 times the absolute value of 2x plus 1 over 3 less than 9 divided by 3. Simplifying the left-hand side, the 3's will cancel out and we bring down the absolute value of 2x plus 1. On the right-hand side, 9 divided by 3 is 3. So we get the absolute value of 2x plus 1 less than 3. According to the second rule, we could write our absolute value inequality as negative 3 less than 2x plus 1 less than 3. The first thing we need to do here is isolate the x by getting rid of the positive 1. So we're going to subtract 1 from the middle, the left side, and the right side of this inequality. Starting with the left-hand side, minus 3 minus 1 is negative 4. In the middle, we have plus 1 minus 1 cancels out. We bring down the 2x. And on the right-hand side, we have 3 minus 1 is 2. The result is negative 4 less than 2x less than 2. From here, we need to get rid of the 2 in front of the x by dividing the middle by 2, the left-hand side by 2, and the right-hand side by 2. We get negative 4 divided by 2 less than 2x divided by 2 less than 2 over 2. Simplifying the left-hand side, negative 4 divided by 2 is negative 2. Simplifying the middle, we have 2x divided by 2 is x. Simplifying the right-hand side, 2 divided by 2 is 1. So the result is negative 2 less than x less than 1. Writing out our final answer in interval notation, we have parentheses, negative 2 comma 1, close parentheses. Moving on to example number 2, we need to solve the following absolute value inequalities. For part A, we have the absolute value of the fraction 2 times the parentheses x plus 1, close parentheses, divided by 3, less than or equal to 0. Notice here that the absolute value is less than or equal to 0. In this section, the rules that we went over only apply when a is positive. In this case, we have a value of a which is 0. So let's analyze this a little bit further. The inequality symbol less than or equal to implies that there's two different situations that we have here. The first situation is the absolute value of the fraction 2 times the parentheses x plus 1 close parentheses divided by 3 is equal to 0, or we have the absolute value of 2 times the parentheses x plus 1 close parentheses divided by 3 is less than 0. The situation where we have the absolute value being less than 0, this is not possible. Recall from the previous section that the absolute value represents a number's distance away from 0. Distance is either positive or 0. It can never be negative. This means that the situation where the absolute value is less than 0 has no solution, and we don't need to work that part out. So let's go ahead and work on the situation where we have the absolute value being equal to 0. From the previous section, we could rewrite this absolute value as 2 times the parentheses x plus 1 divided by 3 equals 0. From here, we could get rid of the fraction by multiplying both sides by 3. We get 3 times the parentheses. On the inside of the parentheses, we have a fraction, 2 times the parentheses x plus 1 divided by 3 equals 3 times 0. Simplifying the left-hand side, the 3's will cancel out, and we're left with 2 times the parentheses x plus 1 close parentheses. Simplifying the right-hand side, 3 times 0 is 0. So we have 2 times the parentheses x plus 1 close parentheses equals 0. The next step is distributing the 2 inside the parentheses to the x and the plus 1. If we do the distribution, we get 2x plus 2 equals 0. Next, we need to get rid of the plus 2 by subtracting 2 on both sides of the equation. Simplifying the left-hand side, we have plus 2 minus 2 cancels out, and we could bring down the 2x. On the right-hand side, 0 minus 2 is minus 2. We get 2x equals negative 2. Next, we need to get rid of the 2 in front of the x. We just divide both sides by 2. We get 2x divided by 2 equals negative 2 divided by 2. Simplifying the left-hand side, 2x divided by 2 gives us x. And simplifying the right-hand side, negative 2 divided by 2 is negative 1. So the result is x equals negative 1. Our final answer for this problem will be written in set notation. I have a set of curly brackets and negative 1 on the inside. Moving on to part B, we have the absolute value of the fraction x divided by 3 minus 1. Outside of the absolute value, we have minus 7 greater than or equal to negative 5. The first thing we need to do is get rid of the minus 7, so we add 7 to both sides of the inequality. Simplifying the left-hand side, minus 7 plus 7 cancels out, and then we could bring down the absolute value. On the right-hand side, minus 5 plus 7 is 2. The result is the absolute value of the fraction x divided by 3 minus 1 greater than or equal to 2. Next, we use rule number 3 to rewrite our absolute value inequality as x over 3 minus 1 less than or equal to negative 2, or x over 3 minus 1 greater than or equal to 2. Solving the first inequality, we get rid of the minus 1 by adding 1 to both sides of the inequality. Simplifying the left-hand side, minus 1 and plus 1 cancels out, and we bring down the x over 3. On the right-hand side, minus 2 plus 1 gives us negative 1. The result is x over 3 less than or equal to negative 1. Next, we get rid of the 3 in the denominator by multiplying both sides of the inequality by 3. We get 3 times x over 3 less than or equal to 3 times negative 1. Simplifying the left-hand side, 3 times x over 3 simplifies to just x, and on the right-hand side, 3 times negative 1 is negative 3. The result is x less than or equal to negative 3. Moving on to our second inequality, we first get rid of the minus 1 by adding 1 to both sides. Simplifying the left-hand side, minus 1 plus 1 cancels out, and we bring down the x over 3. On the right-hand side, 2 plus 1 is 3. The result is x over 3 greater than or equal to 3. Next, we get rid of the 3 on the denominator by multiplying both sides by positive 3. We get 3 times x over 3 greater than or equal to 3 times 3. Simplifying the left-hand side, 3 times x over 3 simplifies to just x, and on the right-hand side, 3 times 3 is 9. The result is x greater than or equal to 9. Next, we write our final answer in interval notation. We have parentheses, negative infinity, comma negative 3, close bracket, union, bracket, 9, comma infinity, close parenthesis. Next, we have a set of practice problems for you to solve. For part A, we have the absolute value of the fraction 3 times the parentheses x minus 2, close parentheses, divided by 5, less than or equal to 0. For part B, we have the absolute value of the fraction x divided by 2, minus 3. Outside of the absolute value, we have minus 5 greater than negative 2. For part C, we have the absolute value of 2x minus the fraction 1 over 10, less than negative 13. For part D, we have the absolute value of 2x plus 9. Outside of the absolute value, we have a plus 5 greater than 3. Okay, so go ahead and pause the video, try out these problems, and then check back with the video to see how you did. Alright, so let's go over part A. Here we have the absolute value being less than or equal to 0. Remember, in this situation, your absolute value cannot be less than 0. So we don't need to work out that part of the inequality. All right, so when the absolute value is equal to 0, we could rewrite this as 3 times the parentheses x minus 2 over 5 equals 0. From here, we could get rid of the fraction by multiplying both sides by 5. Simplifying the left-hand side, the 5's will cancel out, and then we could bring down the 3 times the parentheses x minus 2 close parentheses. And on the right-hand side, 5 times 0 is just 0. So we have 3 times the parentheses x minus 2 close parentheses equals 0. Next, we could distribute the 3 inside the parentheses to the x and the minus 2. When we do the distribution, we get 3x minus 6, and then we bring down the equals 0. Next, we get rid of the minus 6 by adding 6 to both sides of the equation. On the left-hand side, the minus 6 and the plus 6 will cancel out. We bring down the 3x, and on the right-hand side, 0 plus 6 is just 6. The result is 3x equals 6. Next, we get rid of the 3 in front of the x by dividing both sides of the equation by 3. Simplifying the left-hand side, 3x divided by 3 is just x, and on the right-hand side, 6 divided by 3 is 2. So the final result is x equals 2. We write our answer using set notation. We have a set of curly brackets and 2 on the inside. Moving on to part B, the first step is isolating the absolute value. To do this, we get rid of the minus 5, so we just add 5 to both sides of the inequality. Simplifying the left-hand side, the minus 5 and the plus 5 will cancel out, and then we bring down the absolute value. On the right-hand side, minus 2 plus 5 will give us 3. The result is the absolute value of x over 2 minus 3 greater than 3. Next, we could rewrite our absolute value. We can rewrite it as x over 2 minus 3 less than negative 3, or x over 2 minus 3 greater than 3. The first step for both of these inequalities is getting rid of the minus 3 on the left-hand side. To get rid of the minus 3, we just add 3 to both sides of each of these inequalities. Simplifying the left-hand side of both inequalities, we have minus 3 plus 3 will cancel out, and we just bring down the x over 2. On the right-hand side of the first inequality, minus 3 plus 3 cancels out, and we get 0. For the second inequality, the 3 plus 3 will give us 6. The result of the first inequality is x over 2 less than 0, and the result of the second inequality is x over 2 greater than 6. The next step for both of the inequalities is getting rid of the 2 on the denominator, so we just multiply both sides of the inequalities by 2. For the first inequality, we have 2 times x over 2 less than 2 times 0. For the second inequality, we have 2 times x over 2 greater than 2 times 6. Simplifying the left-hand side for both inequalities, we have 2 times x over 2 simplifies to just x. And on the right-hand side of the first inequality, we have 2 times 0 is 0. And on the right-hand side of the second inequality, we have 2 times 6 is 12. So the results will be x less than 0 for the first inequality and x greater than 12 for the second inequality. Writing our answer in interval notation, we have parentheses, negative infinity, comma 0, close parentheses, union, parentheses, 12, comma infinity, close parentheses. Moving on to part C, we have an absolute value less than a negative number. Because the absolute value is less than a negative number, this means that there would be no solution. For the final answer, you can write an empty set of curly brackets, or you can write a circle with a diagonal line going through it. In this case, I used the circle with the diagonal line. Finally, we have part D. First, we need to isolate the absolute value by getting rid of the positive 5. So we subtract 5 from both sides of the inequality. Simplifying the left-hand side, plus 5 minus 5 cancels out, and we bring down the absolute value. On the right-hand side, 3 minus 5 is negative 2. The result is the absolute value of 2x plus 9 greater than negative 2. From here, if you guys weren't sure what to do, that's okay because the book actually didn't do a good job covering this situation. So I'm going to go over it right now. In this case, you could actually rewrite this as 2x plus 9 less than 2 or 2x plus 9 greater than negative 2. Working out the first inequality, we get rid of the plus 9 by subtracting 9 from both sides. Simplifying the left-hand side, plus 9 minus 9 cancels out, and we bring down the 2x. On the right-hand side, we have 2 minus 9 gives us negative 7. So the result is 2x less than negative 7. Next, we need to get rid of the 2 in front of the x. We do this just by dividing both sides by 2. So we get 2x divided by 2 less than negative 7 divided by 2. Simplifying the left-hand side, 2x divided by 2 is x, and simplifying the right-hand side, negative 7 over 2 stays as negative 7 over 2. The result is x less than negative 7 over 2. Moving on to the second inequality, we get rid of the plus 9 by subtracting 9 from both sides. Simplifying the left-hand side, plus 9 minus 9 cancels out, and we bring down the 2x. On the right-hand side, minus 2 minus 9 gives us negative 11. The result is 2x greater than negative 11. From here, we get rid of the 2 in front of the x, so we divide both sides by 2. We get 2x divided by 2 greater than negative 11 over 2. Next, we simplify the left-hand side. 2x divided by 2 simplifies to x, and on the right-hand side, negative 11 over 2 stays as negative 11 over 2. The result is x greater than negative 11 over 2. Next, I'm going to graph x less than negative 7 over 2 on a number line. On my number line here, I marked off negative 11 over 2, negative 4.5, and negative 7 over 2. At negative 7 over 2, I have a parenthesis which opens up towards the left, and I highlighted everything to the left of negative 7 over 2. Next, I'm going to graph x greater than negative 11 over 2 on a number line. So on my second number line, I marked off the same numbers, negative 11 over 2, negative 4.5, and negative 7 over 2. At negative 11 over 2, I have a parenthesis which faces the right, and I marked off everything to the right of negative 11 over 2. Next, we need to find the union between these two graphs. So we need to combine everything from both of these graphs onto another graph. So on my third graph, I've marked off the same numbers, negative 11 over 2, negative 4.5, and negative 7 over 2. We end up using every single number on the number line. So on my third graph, we highlight the entire number line. This means our solution would be all the numbers going from negative infinity to positive infinity. So our final answer, we write in interval notation, parentheses, negative infinity, comma infinity, close parentheses. All right, so we reached the end of our video. Thank you for watching. I'm Professor Diwa, and I'll see you in the next one.